Now let's look at some of the example programs we saw in the slides. This is the first one, and this is the one in which we declare an array n of type integer of size 5, and we use a for loop to initialize all of its elements to 0, and then we print out a column header for the element number, so the index number of each element, and the value that is contained in it. And down here we have a for loop that goes through the array and prints out index and value stored in each element. And I added a return 0 statement at the end. Now, typically, if you have to go through an array and you know when you have to terminate, typically if you want to go through the entire array, plus minus an element, the for loop is usually complements is a good loop to use for that, because you can specify precisely how many iterations your loop is going to run for. Of course, you can have other problems, other situations where other types of loops like the while or do while loop might be more appropriate. So let me run this as it is. And there you go. Elements number 0, 1, 2, 3, 4, and they contain the values all zeros. Oh, I think we have a small mistake here. This is not a D, this is an S string, a 13 character string. Okay, run this again. There you go. Element, value, all zeros. Now what I'll do is I'll make small changes to the program that I have in order to create the other examples that we saw. So for the next one, I am going to initialize the 5 array elements in place. I'm going to use the same values we saw on the slides, 32, 27, 64, 18, 95. And if I do that, this for loop that we were using for initialization becomes unnecessary. We run this, and as you see, the 0th element has been assigned the value 32, the first element 27, third element, second element 64, third element 18, fourth element 95. And let me also demonstrate that this will work even if I don't specify the array size over here. There you go. Still works. Let me also show you what happens if the number of initialization values over here is, so let me put the 5 back in. If the number of initialization values over here is greater than the size of the array, so let me add 100 over here as the 6th or 5th element if you want. You can see already before I even run this, I see this red squiggly line under here and too many initializer values. And this will not compile actually. There you go, error as expected. Let me also show you what happens if I have too few or fewer values over here. That's not a problem. It will still run. The first 4 elements are assigned the values I provided in the initializer over here. The one that is left out, or in fact all elements after that, will be initialized to 0. And just to show you that it's really all elements that are initialized to 0 after that, I'll remove another value from the initializer, run this again. There you see 32, 27, 64, and now the last two don't have any initialization values over here, but the size of the array is 5. So they are automatically initialized to 0. So let me get to another example, and for this, I'm going to demo the hash define preprocessor directive, and I'm going to define this constant, symbolic constant size. I'm going to set it to 5. This over here, the definition of the array is going to change. Going to change that to size to n size, which is n5, like before. Remember, one of the advantages of using a symbolic constant like this is that if I change the size of the array, I don't have to make changes to the number of iterations that different loops, etc., will have to run. All of that is kind of taken care of. And let me put this back in action. And we're going to use this first for loop over here now to initialize the values in the array. And I think in the example what we did was wanted to initialize it to starting from 2 multiples of 2. I think we have an I over here. I think in the example we're using a counter variable j. Doesn't really make any difference what you use. Okay, got that, and run this. There you go. Elements 0, 1, 2, 3, 4. 5 elements as specified by the symbolic constant, containing values 2, 4, 6, 8, 10. And here's the beauty of it now. So this is 5 elements. Let's say I now decide that I want to change the size of my array to 20. Now this will work because now this first loop over here will also run for 20 times. Second loop over here printing out the values will also run for 20 times. And the initialization is happening by some formula, because for this application, this is what I needed. And of course, the definition of the array n is also updated to n20. Run this. And there you go. 0 to 19. So the indices, storing the values 2, 4, 6, 8, 10, 12, 14, 16, 8, all the way up to 40. And now let me make one more modification to this to demonstrate another example. In this one, we have size set equal to 12. We initialize the values of array n manually. 1, 3, 5, 4, 7, 2, 99, 16, 45, 67, 89, and 45. And in addition to that, we define an integer variable total and initialize it to 0. It's actually a very different example, so I'm just going to make some modifications over here. And inside the loop, we're adding each value of stored in the array, we're adding that into the total. Then when we come out of that, we have a printf statement that says total of array element values is, and prints out the value followed by a new line character, and the value of total is what we print out over here. No squiggly lines means no errors are anticipated. So good. We run this. Total of array element values is 383, and I used the same values to initialize array n with, which means this is the same value, of course, same total that we saw on the slides. So let me clean things up for our next example, because that is too different from the one that we're working on right now. So I'm just going to, I already typed it up. So this is the survey example, in which we have 40 responses from different students. And yes, this is the exact same code you saw in the example. There's a frequency array of size frequency size, which is set to 11, and all of its elements are initialized to 0. We have another array integer array called response, which is of size 40, and which contains results from a survey, which are numbers in the range from 1 to 10. The size of this array is set to 11 because we're not going to use the 0th element, but it'll just make our code more readable. Just won't be using element number 0. We have a for loop in which we populate the values in frequency. Basically what we do is we go through response. We read each value, so we start with the first one. So the first response, or the 0th response element is 1. So response 0 is 1. So frequency 1 will be incremented. Next, in this loop, we jump to response 1, which is 2, which means this expression will evaluate to 2, and frequency 2 is incremented. The response 2 value is 6. So in this loop over here, response 2 evaluates to 6. So frequency 6 is incremented by 1. So we're counting the number of times each response is seen in these 40 responses. And we're counting them in this, we're adding them into the correct element in the frequency array. When we're done, we have that array is in statistics, we call that a histogram. We're going to print out the values in that histogram using very similar to what we've already done. We print out a nice table header row, and then we print out each index and value contained at that index location in the frequency array. But look over here, because we didn't use the 0th position in the frequency array, we start this loop at 1 and we go all the way to less than frequency size, so less than 11, because the last index in frequency is 10, correct? Okay, let me run this. There you go. So we have 2 1s, 2 2s, 2 3s, 2 4s, 5 5s, 11 6s, 5 7s, 7 8s, 1 9, and 3 10s. Now let me combine this with the next example. Let me add the printing of the histogram right here. And we can do that by adding another for loop inside this last for loop. So this will be a nested loop. And for this, I'm going to use, and I'm just going to demo that I can actually still use, other than sized here, I can still use integers over here as my counter variables. So I'm going to use the frequency over here. So I'm going to count all the way to frequency rating. So this is the counter variable of the outer loop. Now I'm in my inner loop. So for the number of times stored in the current array element frequency rating, I'm going to run this particular for loop and going to increment my counter variable j, of course, and each time I'm going to print out uh, a character. That character is going to be, I can make it anything really, but I'm going to use the asterisk for that, just like in the example. You can change that, I'll show you that too. If you run this. Oh, one other thing, after I'm done with this loop, I have to print a new line. So I have to eliminate this new line over here and add a new line character after printing all the asterisk characters. Small change. Okay, there you go. And if you want this to be at a bit of a distance, if you want the histogram to show up at a bit of a distance from the numbers, we can do that too. Go over here, add a few space characters, try that again. Maybe this looks nicer. And if you want to use character other than asterisk, maybe something denser, maybe a hash. There you go. This looks even better, I guess. Play around with it. So this we basically covered the the histogram example together with the survey example over here. Finally, let me show you the last example in which we combine the use of arrays with the role of a die 60 million times. And well, we end up really creating a histogram again. We count the number of times each face of the die came up. So I already have that typed up. Open that over here. So this is the example from the slides. Exact same thing. One thing I want to point out over here is that the first for loop uses an unsigned integer variable role to count the iterations of the loop. For the second for loop, we use the face variable of type size t. Why the difference? Remember, we prefer to use, advised to use, to declare a variable as of type size t when we use it to index an element of an array or to store the size of an array. Now, that is definitely happening here in the second for loop because face becomes the index of the frequency array. We're using it to access different elements of this array. So that's fine. But up here in the first for loop, the role variable is only used to count from 1 to 60 million. It is never used to access an element of any array. So that's why it's okay for it to be an unsigned integer up here, but for the counter variable of the second for loop to be of type size t. With the values that we're dealing with, the sizes of the examples that we're working with, it wouldn't make a difference even if you set this to size t or set the size t face variable if you made that an unsigned integer. So let me run this one quickly. Yeah, so frequency is the array of types of size 7. Again, we're not using the 0th element because we just want to use elements 1, 2, 3, 4, 5 and with indices 1, 2, 3, 4, 5 and 6. Makes the code easier to write and read. We use the srand function to seed the random number or pseudo random number generator function. And so yeah, we uh, simulate rolling the die 60 million times, increment the corresponding element of the frequency array by 1 depending on what face came up. And down here again in the for loop, we just print out the values stored in the frequency array that we end up with. Take a few seconds. And there you go. And just if you want to make sure that the srand function is doing its job, we can just run this again and we should see a different set of these 6 numbers in the second column over here. So just remember a few. So this one over here is 9998119, for example. 9998119. And you can see this time we're well over a million, so different number this time. One more time. And you can see that the pseudo-random number the srand function to seed the pseudo-random number generation function is doing its job.